Okay, when we start to talk about trig ratios, we are talking about right triangles. This whole chapter is about right triangles, and so what I've drawn here is a right triangle. Key characteristics, once again, we have to have this right angle down here, okay? Okay, we have to have that right angle. And what I'm going to label this is very important. Okay, A, B, and C. C is my right angle, okay? We also have three sides. So A, B, and C are the vertices, but we're going to have three sides. I'm going to label them in green. It's very important that you pay attention to the details. The details of where does A go, where does B go, where does C go. When we label the sides, where does A go, where does B go, where does C go. If I have A here, the side opposite of A is going to be little a. With the vertex B, the side opposite of B is going to be little b. When I have C as my 90-degree right angle, the hypotenuse is little c. Okay? This is a very important picture to get because when we start to talk about trig ratios, we have to have the little sides opposite their big counterparts because it's going to be very important for us when we're labeling to keep things straight and to understand how these things relate to one another. Okay? So when you in your mind are thinking about right triangles, you need to think about this picture. Okay? All right, let's get started. Alright, so this is trigonometric ratios. You see I have three right triangles here in this area, and what we notice about them is a couple of different things. First of all, we have ABC, okay, and it is not labeled as I had it in that opening part, because this is from your book, and we have XYZ, and we have DEF. Now, what we are going to be doing right now before we get to that part with the A's, the B's, and the C's, is we are going to be looking at these three triangles objectively. Okay? Notice, all of them are right triangles. Okay? Because they all have a right angle. And they all have another angle that's 32 degrees. If we remember the angle-angle similarity postulate, all three of these triangles are similar. And so what we might write is triangle ABC, ABC, is similar to triangle DEF is similar to triangle XYZ. Okay? And so that's what we've got with these three triangles using the angle-angle similarity postulate. Okay? This is going to lead us into saying that if we have certain relationships, like BC over AC, that's going to be equal to BC over AC is going to be equal to EF over FD, right? Which is also going to be equal to YZ over ZX. So all of these ratios are the same. These three triangles are three different sizes, but because they're similar, these ratios of these sides are the same. That's what trigonometric ratios are. Trigonometric ratios are ratios of a side, or of sides. Okay? So, trig ratios are ratios of two sides of a triangle. And I'm going to abbreviate triangle with a triangle symbol. Okay? So that's what trig ratios are. If we talk about the sine of an angle. On your calculator it looks like this, the little SIN, okay? We'll talk about this a little bit later. And on a calculator like this it's the SIN, okay? But it's spelled SINE, we just abbreviated SIN. The sine of A, now here's what we're looking at. We're looking at this little triangle down here which is exactly like the one I gave you in the beginning. So draw this triangle. If we're looking for the sine of A, okay, first we're going to look at A. It's the ratio of the length of the leg opposite, so leg opposite the angle to the length of the hypotenuse. Okay? So the sine of A is going to be equal to opposite over hypotenuse. Okay? And the opposite of A is little a, and the hypotenuse is little c. So A over C. If I'm going to look at B, the sine of B is going to be the opposite leg over the hypotenuse, which is equal to, looking at B, opposite, and the hypotenuse stays the same, so this is B over C. Okay? So, sine is opposite over hypotenuse. Notice I didn't use C. We are not going to find the trig ratios of C. We are only going to use the two acute angles of the triangle. Now let's talk about cosine for a minute. Cosine is going to be a different ratio. Okay? So cosine's a little bit different ratio. And with cosine, we have the adjacent. So if you recall what adjacent means next to. So this is the leg adjacent to the length of the hypotenuse. So this is going to be adjacent leg over hypotenuse. If we look at what this means for A, the adjacent leg is going to be the one next to A. Well, C is the hypotenuse, so that can't be the adjacent leg. So it's going to be B over C. The cosine of B, I'll use blue again, is the adjacent leg, which is A, over the hypotenuse, which is still C. Okay? So cosine is adjacent over hypotenuse. Let's talk about tangent. Tangent is going to be a little bit different because it's not going to involve the hypotenuse at all. It's going to be the length of the leg opposite over the length of the leg adjacent. So opposite leg over adjacent leg. So if I look at A, that's going to be opposite over adjacent, so A over B. And tangent of B is going to be the same, opposite over adjacent leg, which is equal to B over A. Yes, these things are very closely related. And so what I want you to see is that these, we have a mnemonic for these. A mnemonic is something that helps us remember. And the mnemonic is this. SOHCAHTOA. And what SOHCAHTOA is a device to help us remember. So sine, not psi, sine is opposite over hypotenuse. Okay? Cosine is adjacent over hypotenuse. Okay, let me scroll up a little bit. Tangent is opposite over adjacent. Okay? So SOHCAHTOA is what helps us remember these three ratios. And after that, it's all a matching game. Okay? So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Let's look at an example. In example 1, we're going to be finding trigonometric ratios. Remember, these are lengths of sides. And so if I say the sine of r, I know that sine is equal to opposite over hypotenuse. And if you want to, you can write this up here, SOHCAHTOA. Okay? So sine is S opposite H, or SOH. Okay? And the sine of R is going to be opposite 12 over hypotenuse 13. And that's my sine of R. That's it. That's all I want. Okay? So I want to write it as a fraction and as a decimal rounded to the nearest hundredth. So when I plug this into my calculator, I do 12 divided by 13, tenths hundredths, so this is equal to 0.92. Okay? Let's do the cosine. Cosine. When I look up here, adjacent over hypotenuse. Adjacent over hypotenuse. Okay? Adjacent over hypotenuse. So I'm going to look at R here. And adjacent is going to be 5, and the hypotenuse is still 13. So this is 5 over 13. When I round to the nearest hundredth, I get 0.38. That's it. So this is just a matching game. Let's do tangent of S. Tangent of S. So tangent equals opposite over adjacent. Okay? TOA, TOA, OA. So if I've got S, the opposite is 5. The adjacent is 12 because it's adjacent, because it can't be the hypotenuse. So 5 over 12, so 5 divided by 12 is equal to 0.41. Okay? That's all there is to it. So all it is a matching game, and knowing SOHCAHTOA is going to help us figure out which one is which. Okay? So I'd like you to try this next one. I've got another right triangle here for you. You try this one, find the cosine of A, the tangent of B, and the sine of B.